it is not my choice that we use class time for that, but it is mandated, so we did. All right. So really quickly, today what we're going to do, we're going to cover the rest of the lab and the lecture on visualization. We're going to talk about some statistics. We will probably not get to functions or knitter today. I don't believe those are on the syllabus. There's lectures in there and labs, but those are a little bit more advanced and not as crucial as statistics or visualization is. So we're not going to necessarily cover them. I'm comfortable using usually like ejecting those if necessary, and I think it's necessary. So, all right. So I'll wait till my laptop dies. All right. So again, we are back to ggplot2, making some graphics. We've shown some things on how to do some scatter plots yesterday, how to change things in lines. So we talked about two main functions, qplot and ggplot, right? And so we went over a lot of those things in the lab. So again, we'll still be using the data visualization lab. So again, this ggplot2 syntax is you put in a data set and you also put in the aesthetics, right? So again, we're putting x equals year, y equals deaths, and we say geom box plot. So the data we have, again, is indicator information with respect to mortality for children. So some things don't always work as you necessarily would expect. So box plots are a little bit different, right? If you want things to be broken out by box plot or by different years, for example, in this, you either have to do one of two things. You have to make year into a factor, or you have to color, you have to specify another aesthetic other than just x and y here. Because y is continuous, at least in this data set, it prints out one box plot. That's not usually what you want to do. In this case, what we did was we say x is a factor, so we want a box plot for each separate year, right? And this is usually what you want. Y, we're going to put deaths, and we do box plot. So again, we can change the labels on this, and we'll show you how to do that. But this gives you a box plot for every single year, and you're looking at the medians over time. So, thankfully, we're seeing child mortality decrease over time, and you see some of these data over here because there aren't that many countries that had data before, for example, 1800. Yes.
Did you have to make year into a factor in your code before you did that?
So we're doing it on the fly. So the data set, good question, long. If we go to use that data again, year will still be treated as a continuous variable. Here, we can say factor within the code, and it will make it a factor on the fly. Okay? So it's similar to saying year is equal to factor year, and then run the plot, but you've not changed anything about your underlying inherent data. Good question. So we're going to go into some other plots because I think getting a whole kind of smattering of different types of plots is useful. So right now we're just going to subset some of the years. We're going to take anywhere from 95 to 2000 or 96 to 2000. So we're just going to plot a few years. And we're going to make a ggplot that's a little bit different of a kind of box plot. So box plots are great. They summarize the data well, but sometimes you also want to get a gist or a feel for the underlying data. So what we do is we take this subset of years. Again, we're only plotting 5 years. Again, we're making year into a factor. Again, we're plotting deaths on the y-axis. And we're making a box plot. And then we're passing in this argument that's specific to the box plot function, or the geom box plot function, outlier.shape equals NA. Which means, let me go back, when you have an outlier, right, 1.5 times the IQR, either below this 25th percentile or above the 75th percentile, it's going to put a point there because it calls it an outlier. When we say outlier shape equals NA, it says remove them. Don't put those points in there. So whatever you called an outlier before, right, you put a point there in the box plot. We want you to say don't plot those. We'll plot them ourselves. Okay? So if I do this box plot and rerun this again, right? If I run a box plot where outlier shape equals NA, you're never going to have the box and whiskers, but you're never going to have the points that are considered outliers. So we're just saying remove those. We don't need those. Because afterwards, we're going to plot the points. What geom jitter does is it jitters the points. So jittering just means it's going to add some random noise to the data. Because if I did geom point, for example, on this data set, and I wanted to plot points, remember, year is a factor. So all the points in this data set have the same exact year. So they would just be points on a solid line. So I'm going to pull up the code really quickly and show you exactly what I mean. So I think it's a little bit better for visualization. I'm going to just run all this. I'll make this bigger, and hopefully plots will actually show up and not yell at me. Okay. Okay. Let's clear out that. All right, so again, let me just do this where I say outlier shape equals NA. We can zoom in. So again, it plots the box plot, but it doesn't plot the points. That's what outlier shape didn't do. If I don't put outlier shape equals NA, and I just do box plot, oh, there are the plot. There are the points for the outliers, quote unquote. Okay, so I said just don't plot them. And the reason we're using geom jitter is because if I say geom points, we're going to get everything stacked up on each other. Right? Because they all have the same exact year. This is a factor, right? There's no variability here. So what we want to do is say, hey, I want to see where the data still is, but I want to spread it out a bit. So geom jitter can take in pretty much two arguments that are relevant, height and width. If you say height equals 0, it says don't change anything about the y, right? That's what it means by height. Don't change the value of y. But by default, it will change some of the data in the width. It will change where it plots it. So for example, this point still has year 1996, but it added a little bit of noise to it, so it spread out the data. Okay? So geom jitter will help you in plotting factor variables, but spreading out the data so you can see it and it's not plotted on top of each other. So this is another way of showing kind of a box plot that says, okay, here's how you can kind of get a gist of it, but you can plot the points on top of it. So you can get more of a feel of the entire data. So again, order matters here. So I'm just going to flip the script and run these, do the exact same code. Let me run the jitter command. But I'm going to run the jitter first, and then the box plot. So what do you think is going to happen? It'll still plot things, but the boxes will overplot on the points. Okay? So if we do that, that's because by default, a box plot is filled in white. What we can do is we could say fill equals NA. Fill is missing, right? So the fill of this box was removed, so it's actually transparent. But that's not super helpful either because it's still hard to see where the box is. So we could do something, for example, where we change the fill to missing, but we say color. Somebody give me a color. Blue. So it's plotted on top of it, and it's transparent so you still see the points. So the box is not in the background, points aren't plotted on top of it, the box is plotted on top of the points, but it's a different color, and we can still see the points behind it. So it's a good summary of the data, but while also giving you a kind of good idea of the distribution of the data on top of it. So, again, how would I find out that outlier shape and all these things are arguments? I would go to the help files, read the help files, see what's in there, and customize it. I mean, practically in some respects, what I would really do is Google how to do this geom_box plot. and see if anything came up immediately. Because here's the thing, Google is amazing, right? It's a search engine that's optimized. It will search for exactly some of the things you want to do, and there's a lot of code out there. So quick R, I think R cookbooks have a lot of examples on how to do specific things in boxplots, or sorry, in ggplot. But sometimes if you can't get it to be exactly what you want to do, I would highly suggest, or what you should do is go to the help. Okay, so facets. Facets allow you to break things out into individual subplots. So again, we're going to take the data. In this case, we could have said data equals sub, but we're just going to pipe it in there. We specified the aesthetics, year and death, again, right? So year is continuous. We want things connected by lines. We don't want to just plot points. And then we add facet wrap. And again, so facets use this interesting syntax formulas. So before it was y tilde x, right? And there is a way to do y tilde x in this in facets, but really what you usually do is say, I want to do a facet by country. That's what we're saying here. So again, the reason we're using the subset of the data is there's like, 100 countries or something like that. If you did this with the full data set, you'd have 100 different subplots. So what is the nice thing about this? Axes are exactly the same. They are fixed together. You can change that. There is an option in facet wrap. But normally what you want to do is compare things across countries, right? So here, we can look at United Kingdom and Afghanistan, and we can look 0 to 5, 0 to 5. They are exactly the same. So facet keeps the x and y axes fixed by default, which is usually what you want to do, right? So if you want to do a bunch of subplots and keep the same things fixed, you can. There's also, I believe, yep, we do this. So you can tell it the number of columns and the number of rows that you want to do. So maybe this plot, okay, these three, I can compare horizontally, right? I can compare, oh, does this one get higher than the others, right? And this way I can compare, oh, what's the trajectory over time look like? But maybe you just want to say, I really only care what the shape of the thing is, the shape of this function over time is. Then I want to stack everything where, for example, time is on the x-axis and I want to see what's going on. So we see, for example, Sweden starts out around in the middle and it slowly decreases, similar with the United Kingdom and the US. Afghanistan starts out, the data first off starts out a little bit later, much later, and it has a steeper decline, right? But I can see things visually if I stack it on the rows or the columns. And the way you can specify that is n col equals 1, or n row equals 1, for example, and we'll put things in as many columns. So I'm saying it depends on what you want to compare the y or the x together. And sometimes you want to do both of them, and you can say n col equals 2, n row equals 4 at the same time, and it'll do a whole panel. So that is how you do it with the ggplot syntax. If you want to do it with qplot, the quick way, you say facets, you still use this formula syntax, and you say country, and we get the same thing that we showed before. Okay? Facet, also, I want to be clear. Qplot and ggplot2 still make ggplot2 objects. So if for some reason facet wrap is something that makes sense to you, you can make this qplot without facets in there, and then on the right hand side say plus facet wrap. So let me demonstrate exactly what I mean. Okay. Instead of, you say facets equal country, and then put this on multiple lines so you can see what I mean. You don't have to choose, for example, oh, I know how to do this in qplot and I want to add facets, but the adding thing is the gg, you have to use the ggplot command to get the initial plot. You don't have to do that. So I'm saying qplot, you can still add things to qplot. That is what I'm trying to demonstrate here, and it'll give you the output. So we don't demonstrate it, but you can put more than one facet. And again, this formula syntax, you say tilde, country, and something else, right? We don't have any really any more things to kind of facet on here, but I'll make a random 0, 1 binary variable that so I can demonstrate more than one thing.
What does the x2 refer to?
X2, in this specific case, we don't have any other data. But I'm going to make one. So sub fact is sample. So if you want to facet on more than one thing. So let me show you. Replace string. Okay. Give me 1 second. Size equals yeah, let's do this size length sub or nrow sub. So I'm just putting okay. So let's say there was another variable. This was a low year or a high year. Let's say cholera was big that year, right? I'm working with this project with cholera. That's why I just cholera plus Johnson. You know. So we have Afghanistan, a high year. This is what the trajectory like. Afghanistan for the low years, Rwanda for the high years, Rwanda for the low years. There are differences between these two, although they look very similar. So that now does all combinations of the observed data, right? Country and high-low, and I did say there was a way to do y tilde x. That gives you a different style of faceting. It switches up the order, but it should. So let me see. If we did it this way, let me, for example, say. So we know there's 4 highs and 5 lows, I believe, or 5 highs and 5 lows for each one of the countries. So, for example, if I say NCOL is 2. We'll separate it so that NCOL is 2. I gotta switch them up. So it might not look like I know what I'm doing, because in some respects I don't exactly know what I'm doing, because the syntax sometimes is a little bit. The syntax is fixed. I don't use that many multi-facets. I usually use one facet at a time. But here we have high on the left, low on the right, right? So you can specify multiple factors and then set the NCOL things. So now we're looking at all the highs and comparing them and the lows. And the reason I say it looks like I don't know what I'm doing is because that's how I code. I mean, I try something out, it doesn't look exactly the way I want. I change it, I look at it, I change it, I look at it. Right?
So it's NCOL that will arrange the graphs into different columns?
NCOL will say how many columns do you want to present. And so let me go back. So NCOL says there's 2, and it'll put the 5 over and over and over again. So there is facet wrap, probably something more visually pleasing, facet grid. So NCOL says I want 2 columns, so it's going to start filling things in column-wise, right? R does almost everything when you're thinking about filling something in. For example, a matrix or something like that, column-wise. So facet wrap allows you to do faceting. There's also a function called facet grid, right? Which does a grid of facets. The behavior is different, right? It's the same code I had for facet wrap. I didn't specify NCOL, but you see they're different. So high and low are now the titles on the right side of the axis, and each country is separated like this. So sometimes this is the way you want to present the data to compare it, right? For let's say high or low cholera years, or you'd switch up if you switch up the factor order, now high and low are still separated, but now they're the columns versus the rows. Okay? So facet wrap and facet grid are two important functions that will allow you to separate things into subplots. Now, I do not know, in order to get fun things like annotations where it's like A, B, C, D, E, F for papers, that takes a bit more time, a bit more energy. We're not going to necessarily cover that. You have to essentially put in another data set that says like Afghanistan high, A, Afghanistan low, B, and so forth. You have to pass that into another function. All right, let's go to the lab. Lab part 2. So Leslie and I are going to float around. Let me pull up the visualization lab. The key should be online as well. So if you want to just run some of the code and go through kind of making these plots, I think that's totally fine. So part 2, we're plotting the average ridership. Again, this data set that we're using, if we scroll up a bit, it's this average data set, AVG. Plot the average ridership by date with one panel per route. Okay, using facet wrap or facets or facet grid. But again, you can use facets in qplot, or you can make a qplot and then add these other facet wrap or facet grids. And again, if you look at the help files, there are ways to free up the scales of the x and y axes so that you can allow the x axis to be fixed across all the plots, but allow the y axis to move freely depending on the subplot, or the other way around. But by default, the nice thing is they're all the same, so they're comparable. All right, so we're just doing 3 and 4 right now, so we'll give about 5-10 minutes for that. We can download the lab keys. That might be a good Yeah, so if you just run Yes. So yes. So just try back.
Let's just
But because we sorted
alright, yeah, makes sense.
no, yeah, that's a good question. Yes.
What do values equal how, EAL?
So I defined a like a string of colors. Yeah, like pal is blue, green.
Okay, yeah, I didn't want, that was two from yesterday, that's why.
Yeah.
Great, thank you.
Mhm.
Okay.
So who's been able to get some facets? Some people here and there. Yeah. So there's no difference between facet and grid. So there's just two functions, facet and graph, which presents the facets in one way, and that's the way to present facets where you specify our columns and rows, and then facet grid is just a different way to present facets, and it labels things a little bit differently. Yeah, so they're just two different ways to do facets. They have different options, and they're presented a little bit differently on the screen or on the top. So Qplot is just kind of like shorthand on Qplot. So Qplot syntax with the AES and that kind of stuff is a little bit, especially unintuitive to an R user that's used base graphics for a long period of time. So it allows you to make things quickly. But ggplot 2 or ggplot is kind of the it's just in a lot of respects it has no default, so it's kind of like the idea that you start with the ggplot command will just give you like what is x, what is y. There are nothing's added to this one. It's just kind of like a blank canvas. This should be the x, this is y, and we add layers to it. So that's kind of the thinking, right? So in some respects, someone wrote a book. And I was like, this is a theory of graphics, like how you should do things. Like something the canvas, define the variables, and then add things to it. And this guy had to go to this like a piece of software, like keeping these principles kind of intact. And ggplot, like make a plot. Here's x and y. What's the date on these? And it's like add June, add points, and then there's other things on top. make it black and white, make things bigger, make things smaller, and then next labels, Y is good. Those things you just add to the file. Whereas qplot, you can put that in arguments, but the nice thing about it, it still gives you back to ggplot2 object. So if you're like, oh, I know how to do facets like with plus facet grid, but I don't remember how to do it with qplot, so you just set up qplot like points or something like that, and then you just add to it. So ggplot2 is the package, ggplot is the function within that package. There was a ggplot package like almost 10 years ago, and then it was rewritten. So whenever we're talking ggplot, everybody means the package ggplot2. Right? Yes. So ggplot is a function within the ggplot2 package. Got it?
Looking at item 4.
Item 4.
I'm not writing it, I'm reading the code.
Mm-hmm.
So I'm trying to relate your question to the code that is written. But we're not there yet.
Okay. So let's go over number 4. So the code we have on there is, we say qplot, the x-axis is date, the y, we want to plot the number, and again, this is riders, this is average ridership. We have to make sure it knows which data set we're using. Facets. So again, we want a different subplot for each day of the week. So day is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Color by line. So remember the purple, the green, the banner, and all that kind of thing. So each line will be given, each bus line will be given a different color. This area right here, values equals PAL. PAL is nothing special. PAL was actually defined above, just so that the banner line was given the color blue, the green line was given a dark green color, the orange and purple were given their respective colors. So this was run previously. PAL is nothing special. PAL is not a function. PAL is something we defined. So this is what you get. So again, it's broken out by different days of the week. That's what facets will do. And it's colored by the different lines, and the legend is given on the right-hand side. Or a guide. That's at least the terminology from ggplot2 is a guide. Also, we were discussing this. There is, for all intents and purposes, no ggplot1. That doesn't exist. Right? It did, and it's irrelevant. It was old. The code is now completely gone. It's ggplot2. Whenever anyone talks about ggplot, that's the package they mean. They don't mean another package, ggplot. But the function to create a ggplot in the ggplot2 package is the function ggplot. So ggplot2 is the package, but there's no ggplot2 function, for example. So, and again, the reason we're using qplot versus ggplot is just because it's quicker in some respects. The code is a little bit more condensed, but however you conceive of it, or whatever makes more sense to you, I could have done the same thing where I say ggplot data equals average, AES. So I say the color is the line. So I say these are the aesthetics of my data. This is the data. And then I say plus facet wrap. And I say day. And I'm gonna make I made a slight error here. I'm gonna say it was intentional. It wasn't. But I made a slight error here, and I'm going to run this command. I'll run these two commands, and it says, what's going on? I ran the first command, and it gave me this plot, and it's completely empty. And then I try to run this command, it says, invalid argument in your operator. What are you talking about? You told me I could add things to plots. So that is because this command to R is completely fine. It's a full command. The command is over, right? So when you run that line, it executes. Because these are on different lines, if you put plus at the end of the line, R knows this isn't over yet. This line isn't done, right? So that sometimes you will get things like that where if you made a completely valid piece of code and didn't end it correctly. So I plotted it, right? Well, no, not exactly. I made facets, that's true, right? So this code made this empty plot. So what happens is in qplot, by default, it'll know to plot points. That's another thing. It's got a default that says you want to do a scatter plot. You want to do points. If you use ggplot, it's going to say, this command is only saying, I'm making a blank canvas. So you have to add points to it for it to actually plot points. And again, we're going to do some fun things here. Now it's faceted. We have different lines, and the colors correspond to the actual colors of the line. Okay? So, sorry about that. We did put a breakpoint in a bad spot in the code. That's my fault. So, we wanted you to change the X and Y labels. So the way you do that is you add labels. And those labels, the way you define them is XLab and the YLab functions. Right? So you're saying, so again, first plot was something I had run way up here. I saved it up here. So this was the first plot we made. And again, let's look at it. Oh, it's beautiful. It's over time. These are the different numbers of lines. This is the first plot we made. And remember, I saved it as an object. Now that I have that object saved, now that I'm like, okay, this is what I want to plot. Now I'm going to make it better. Now I'm going to make it more customized. Now I'm going to make it more readable. So now I say first plot. This is an object. I add X label is year, Y label is number of people, plus theme BW, which I'll show you what that does. It says make it a black and white type of theme. Make it a black and white type of, I don't know what the right word is. I forget what it is in Stata. It's like, what's the economic one? They're not themes. Palettes, no, that's not right either. Mono, S2 mono, whatever that is. Style, sure. I think it's style. I don't know. It's a scheme, not a theme. A scheme. So in Stata, it's schemes. This one is themes. So it's saying a black and white theme, and I'll show you. I'll run this, and I'll run it without the theme. So okay, let's zoom in. Okay, look at the background. Well, now X and Y labels are set to be things with capitalization, something that's a little bit more intuitive, right? And let's run the exact same thing, and hopefully we'll be able to flip back and forth. What do you note about the background? Probably nothing because this projector is terrible. God. So the background, looking at my screen, if we switch back, there is when you plot something in ggplot2, there's this gray background and white lines. The black and white theme, right? It's hard, it's impossible to see. But if you will, I can take a screenshot of it, yes. And then let's flip back. So, how about before I take a screenshot of it, I think we'll go back to the lab in 1 second. But this brings me to devices. This brings me to saving your plots out, right? There is an export button in RStudio. That's great. That is not what you should be using to export plots. You should be doing it in code. And the way you do that in R is you open a device being a PNG, a JPEG, a bitmap, or a PDF usually, running your plot command saying plot, 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 and then you turning that device off. That's the way it's done in R. So I'll show you the commands for that in a second. But again, these are the functions that you're going to be most interested in most of the time. BMP for bitmap, JPEG, TIFF, PNG, or PDF. The first four, you can save one plot out to it. PNG can only have one plot. TIFF can only have one plot. And what I mean by that is whatever you're seeing in that zoom, right? It can have sub-figures and all that kind of stuff, but there's only one picture saved. PDFs can be multi-pages, can be multiple pages. Everything else, one shot. So the way you do that, for example, if you want to open a PDF, you want to make a PDF, you say PDF, the file name, and you put some options. In this case, height and width. Look at the help files. They have inherent resolutions, all that kind of stuff in here. You want something of a different size, different shape. You want a 600 ppi resolution figure for your journal or a TIFF. There's options in there to change that. Then we run the plot commands. Let's say this made a plot, and then you say dev.off. It's not pdf.off. It is not png.off. It is dev.off, and you put these parentheses there. So it's saying turn off this device. If I run this command and run these plots, on my computer there will be a file named filename.pdf. You cannot open it until it says until you run dev.off. It is just an open PDF device that it's dumping information into. So, for example, we changed the X and Y labels. I'll talk about GG title in a second, but let's just say we made a figure called Q. Okay? This was something I saved out. For example, like first plot. What I would say was PNG, deaths over time, print Q, print out this plot, dev.off. It'll usually tell you some weird thing here to say, this pretty much says, you turn this device off, this is the device we're currently on, which means when you're plotting, the device that you're actually working on. And then I want to see if that file exists, and it does. That's all I'm saying. So this saves something to my disk. So I made, for example, a PNG. So what I'm going to do, I'm going to open a device. PDF, black and white theme. .pdf. Okay? Now, when I run these commands, that's interesting. Okay. Let me just open. Sorry. I don't know what was going on there. That was a little strange. So I open the PDF. I run my command. Nothing came up. Nothing plotted. I run the same command. I run the command with theme black and white, and I'm going to post this immediately to the website. You guys can see what I mean by the differences. And then I say dev.off. So when you open a device and start plotting, nothing's going to come up down here. Nothing's going to come up in your interactive screen because it's saying dump this out into a PDF. So really quickly, added PDF. So if you go to the website, intro to R, black and white theme.pdf. I can't make that any bigger for some reason. Black and white theme.pdf. Obviously it takes a second. I wonder if I can see it any better here. Nope, you can't see it any better with respect to the theme. Great. Maybe on this. Nope. Projector. Yeah. So, give me one sec. Okay, so in a minute, the website should have a PDF link to it out there, where it actually shows you what this looks like. But again, you open a device, you dump out plots, then you save the device, and then lastly, for this plot, so So you open a device, you plot, you say dev.off, it turns off the device. Now you can open that thing. Now that thing is saved and openable, being able to be opened. If you try to open it while it's still open in R, it'll say either it's corrupted or it can't be viewed or something like that. And then lastly, in this example, I use the theme command. So the theme command changes things about the overall gist of the plot. And if you look at the help on theme, there are many, 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 many options. In this case, I want to say all text, any text in there, the title, the legend, whatever. I want to say it's size 20, right? So you'll see, compared to other things, other plots we've done, the axes and all the labels are way bigger. Okay. Also, those who use Stata, I think this is the way you should plot numbers on the x-axis, not this way. Right? So by default, for example, in Stata 2000 will go along that. I don't read sideways, so I don't think the text should be sideways. You can do that if you want. I'm not going to show you how to do that, but yeah. Then if you look at the guides command, which we'll talk about in a minute, you can change things about the legend. All right, so really quickly, if you go to the can someone go to the website? The very first link should be to the PDF that I plotted out. So if you go to johnmichelli.com/intro to R, there should be a link for the PDF, right? You look at it. Do you see the differences between the two plots? The first one doesn't have theme BW on there. The second one does. And you see the backgrounds are different. The theme is different. The overall gist of it is different. There are multiple themes. There are many, many different types of themes. Find one that kind of makes the most sense, looks the most intuitive to you. Or the default. It's the very, very top. It should say PDF. So if you refresh your page, if you had it already open, if you refresh your page, the very first thing on the website, it should just say PDF.
Skip right over it.
Yeah. All right.
What's the difference?
Did you looking at them? The background. Well, at least cursory the background.
First one's gray.
So one of them uses the regular theme. The second one uses this theme, black and white. So let's go back to this plot because some things were added to it that we didn't discuss. Okay. So we talked about how to make the plot. XLab and YLab do the labeling. GG title is the function to change the title. The reason that it's not just title is because there already is a title function in R, so you have to use GG title. You give the main title. You can also give a subtitle if you'd like, right? And this is the way it's presented. Some journals like figures with titles. Some don't. Some require it be no title and everything is in the legend or is in the caption, for example. But for doing exploratory analyses or analyses for collaborators, that's totally fine. This is the way you do it. So XLab, YLab, GG title. Okay, change the background, change the theme. So, when you want to change sizes and colors or something about it, it's usually about text a lot of times. Again, you use the theme command. And in this case, we're doing two different things. We're setting the title size to be 20 and the text size to be 12. And the way the syntax works, you have to use these element text functions to define them. So element text, we're going to look at the help file in a minute. It has a bunch of different options of things you can change. In this case, we're saying, I want the theme, I want the text to be size 12, I want the title to be size 20. You see the titles to be big, the axes to be big, but the text down here is small. So title refers to not just the main title, but also the titles and the labels of the axes. And the legend, right? You see this is big. So, again, there are more things you can put into theme. So axis.text, right? So I want to have more control over the sizing. I don't want to just call all text to be a certain size. For example, I want the axis text to be a certain size, the title to be a certain size, the axis titles, right? So these are the labels, to be of a different size. So the main title is size 20. The X and Y labels are size 16, and the text for the ticks are size 14. So this is just an example of how you can change your plots to make things of a certain size to have more readability. And then legend.position. Where do you want the legend to be? You give it two numbers. Where do you want it on the X and where do you want it on the Y? And you give them in relative coordinates. So 0.9 means 90% of the way in the X-axis. 0.8 means 80% of the way in the Y-axis. Right? Not the X and Y actual coordinates. Not 2105. Right? So this is moving the legend to a different spot in the figure. Also, one of the instructors in Biostat, Elizabeth Quantoni, has instilled in me, ingrained in me, legends go inside the plot for me. So I think this is a huge waste of space. I have blank space here where no data is. I suggest you move the legend inside. So for example, I would put the legend to maybe 0.5, 0.8, and just have the information here where it's covering no data. Right? Rather than having it as a second thing. Also, look at the slides.
Isn't that inside?
It is inside. It is inside, and that's fine. If you look at the slides, so I do.
It looks inside.
Yeah, if you look at the slides online, it looks very different than it does up here. You can see that it's actually put in there, but it's not. It doesn't look that great. I think it still should be like. There's a white box around it. Right? Everything on this projector is white, so it's really hard to see. But lastly, we use the guides command. The guides command, guides in ggplot2, that's what they mean by legends. Right? The guides command, the guides function is what you use to change legend properties. So if you look in guides, there is an argument for color, fill, size, any aesthetic that you used. In this case, because we colored things differently, we map this variable to color. That's why we're changing the color guide. If you change the color and the fill, there's going to be two different legends. The way you change things for that specific aesthetic, in this case color, you say color in the guides is a legend. And for example, we want to change the title to be a capital C country. And there are other arguments in all of these. In for example, guide legends. So title, display, values, all that kind of stuff. So again, if you look on the slides online, you'll see that this is placed within there. This slide is completely lost on this projector because I think that if you look at the slides on your computer, you see the difference between the two. This is no longer has a big white box around it, and that's because I defined this object called transparent legend. I said it's a theme where the background of the legend is transparent. The key, these little boxes here are all the keys, have fill and transparent colors. So if you look at the slides on your computer, you'll see that these blend in with the background. Right? They're transparent.
So once you create that transparent legend as an object,
Mhm.
then you can apply it to any
Exactly.
plot that you make. So you can make your own little dictionary of formats that you would
Yep.
like, and then
Exactly. Mix and match them, and that's a great point. So we assign this to an object. This has nothing to do with the data associated with it. Right? It's just saying, I want this theme where these properties exist. And it didn't matter if this was a scatter plot, a histogram, it doesn't matter. I can say Q or whatever plot plus transparent legend, and it'll make that legend transparent, no matter where it is, no matter the position, and so forth. That's another reason why ggplot2 has become adopted in a lot of respects. It's easy to make quick customizations or custom functions to just add to your plots. Okay. So we're going to move on in the lab. So again, this last example should make more sense now, right? This was a plot we saved before. We're changing the labels. We're changing the size of all the text within there to be of size 20. So I believe in the key in the lab, yeah. The key and the lab are a little different in the sense, in the lab itself, we added this text to say line type is another aesthetic and certain things like that. But in the key we didn't. So scale underscore line type manual is another thing. So like I said, there's aesthetics for color, fill, all that kind of stuff. There are different aesthetics for different types of plotting. So for example, for points, there's color and fill. For histograms, there's fill and color as well. But for lines also have a different type of aesthetic that you can change. One of them happens to be line type. Right? And so when you want to map something to a variable in your data set, you have to use this AES. That's the important thing. If you're not, or you can use qplot. Right? If you said qplot, line type equals type, that should work.
Can you explain that again? When do you need to use AES?
When you are mapping something, a property of the plot, to a variable in your data set.
Okay.
Right? So if I say line type, so let me show you 2 or 3 different examples. And then we'll break in, do this. So let's make orange. So we see, it's not really great, but you can see, let me zoom it in. Come on, where'd it go? So you should be able to see that it's different, right? Luckily here, there's some gap in the data. There's some of it's, so A lightings are solid, boardings are dashed, and averages are dotted, right? So they're separated. So it's mapped to different things. But if I wanted to say, for example, this is very different. Line type equals dashed with no aesthetic around it, no AES. I'm just saying, set it to be this. I want a dashed line. I don't want you to map it to any variable. Okay. Note also, it only shows one line. It doesn't do it separated by the 3. Okay. So inside AES, you're usually mapping something, some sort of aesthetic, a size, a shape, a line type, to a variable to have them separated. But when you don't do that, you're usually setting it relatively globally for that object. Yes.
How do you define which aesthetics do you want by type?
I don't understand what you mean.
So like if you want to do dash for like a particular one, is that what you mean?
Yeah, when you use like AES
Mm-hmm.
line type equals type.
Yes.
We just put line
To something. To
Yeah.
solid and dashed. So scale, line type, manual. So for mostly anything that you're doing, instead of coloring by color, fill, whatever, there should be a scale underscore that thing. In this case, line type. There's a scale underscore color, scale underscore fill, manual, where you can set the values to be a specific thing. And the way we do that is in a way where we can name the things. So the way it says scale line type manual. So I want to manually change the line types, right? So up here, we said map it to type. And the 3 types are A lightings, A boardings, or boardings, and average. So here we say the values are equal to dash dash solid. If I didn't put any names there, it would be dash dash solid. In whatever order it went, whatever order it was given. And the order, if it's a character, will be in alphabetical order, just like factors. If it were a factor, the order in which we give the line types will be mapped in order of the factors. Or, so you either give it dash dash solid. Let me demonstrate what I mean. So the way this goes, right? Alphabetical order. A lightings is first, boardings is second, or average is second, boardings are third in alphabetical order. So if I just do this, let me zoom this in. We see when I say dashed, dash, solid, and didn't put any names, it says, okay, you want the first two to be dashed. It's done in alphabetical order because this thing isn't a factor in our data set. If it were a factor, it would do the first factor was dashed, the second factor would be dashed, the third one would be solid. Right? But if you want to specifically map the type to a specific line type, or line format, this is the way you do it. You actually name this vector. So this is just a vector where we say a lighting is equal to dash, board is equal to dash, average is equal to solid, and then ggplot2 will understand that, okay, that's fine. They are still going to be presented in alphabetical order in your legend, but they are going to have the correct line type associated with it because you named them. Right? So this, what I did in the second case, right, is much more robust because you know it's visual. One, you can read this and know what's happening. And second, it doesn't depend on the order. So if you reordered a factor, that code will still work the exact same way.
And is there any way of like, I want everything to be dashed, but those two?
Everything to be dashed but those two.
You have
Good question. So you can do this. I'm not sure. So I don't know. Let's go to the lab. Let me think about that. So let's jump out and look at which part are we on? Part 3. So let's look at 5 and 6. Number 5 and 6, and I'll think about that one in a minute.
By the way, I
Close one. All right, so we're going to go over these. Definitely want to get to stats today. So, again, plot the Irish ridership, changing X lab and Y lab around. We can change the title with GG title. We change the background. Again, there should be a scale underscore something underscore manual if you want to do things, if you want to change things manually. For example, scale color manual. We did that with the boardings. We did that with the different lines, right? Purple, green, all that kind of stuff. We just didn't put them named, right? We just said blue, dark green, purple, orange, because we knew the order in which they were in. If we had named the vector like we had done here, we could say purple equals purple, green equals dark green, banner equals blue, and so on and so forth, and put them in there if it was scale _ manual. So this is how you can manually change the colors. Otherwise, it's going to use some sort of default. Okay? Usually the default's not that bad, but sometimes you really want to customize it. Scale _ there are a lot of different other types. Scale _ manual. It's a color manual is one way you can do that. So again, you see the manual. There's color, fill, size, shape, alpha, line type. Alpha, we'll talk about, does some alpha blending, right? So it does some opacity, so you can see things in the background, which we'll talk about in the next slide. All right. So again, we showed you how to do histograms a bunch of times, right? You put in a vector, you can change the number of breaks. This is how some of the mortality data looks like for all over the years, right? In ggplot2, we either use genome _ histogram, or we say histogram and genome in qplot, right? And if we put a fill, we will have a different histogram for each separate country. That's fine. Not very easy to see. Not very easy to see which countries are which, right? But you can do that. Sometimes we want to change the opacity. Let's say alpha is 0.7. So this does some alpha blending. So again, doesn't help us out. But sometimes when you have overplotting, when you have a lot of plots of scatter plots, I think one of the examples we gave in the homework, it was like a whole bunch of plots in there. So you can use opacity to kind of see where the data is. But sometimes we want to do something a little bit different. Histograms are great, but let's do densities. Right? So if we did density, and we fill based on country, we can now see the distribution of child mortality over all the years for different countries. And if I didn't put alpha equals 0.07, I'm going to show you what happens. What do you think happens if I don't change the opacity? It's hard to see pretty much anything in there. Right, so it's great, but okay, what's happening with this green one back here? I don't know. Right, so we're going to change the opacity, and so now we can see what's going on. Right, we can follow the line. So alpha blending and changing some of the things are really helpful in here. So sometimes I don't want to fill the things. I don't want to fill the things by the color. I just want to see the shape of the lines. So instead of, so again, the difference between this, fill equals country, color equals country. So it's colored, it's coloring the lines by different countries, and we're setting the alpha level. Don't worry, so we shouldn't have set the alpha level here because we don't necessarily need that. But you see, okay, this is where the distributions of the infinite mortality looks like over all the years. One thing I don't like about this plot, because it's a density, it thinks it's supposed to like make a thing that you can fill in. So it puts these lines at the bottom, and it does this weird thing at the end. I don't really like that. So one way you can get around that, one way you can make the density plot with just lines, and again, I could have used qplot here, but I used ggplot. I say geom line, and the statistic, or the thing I'm actually mapping, is the density. So this and this are similar. Two things are different. Boxes versus lines. And the second thing is, this has these lines that turn this into like a polygon, into some shape. This just plots the lines on top of each other.
And were the colors just randomly selected by whatever is happening in the back?
There is a default palette, and then they're done in order, in the order of the alphabetical, because it's not a factor yet. If we made it a factor, they would be done in the order in which the factor was given.
What is alpha do again?
Excuse me?
Alpha.
Alpha, in that example, didn't do anything. Alpha here changed the opacity. You can see through the thing. So pretty much, in a lot of respects, if you had an alpha of 0.1 and you had 10 points at the exact same spot, that is equivalent to one solid point. Pretty much, right? So 10%, 10 of them on top of each other, you have 100% alpha, which means you can't see through it anymore. Right? So sometimes
I guess one the explanation cannot
So,
the lower the alpha.
give me 1 second. Yeah, I'm listening.
The lower the alpha,
Lower the alpha, the more opaque it is, the more translucent it is. 0 means you can't see it at all. 1 means it's full. Right? What? That's not a bad blob of points. Let me see. Let me do this. Sorry. That's a little bit better of points. So it's harder to see, but the idea is, so I'll go back to, let me pull the code to the side. So what I did was I said, give me this data set. This is 10,000 random normal data just plotted against each other, right? X and X, I just put them in there. Geome point alpha equals 0.1, which says every single point has about a 10% translucent, or actually 90% translucent property. So if you had 10 points on top of each other, it's going to be really dark. So this allows you to see kind of where the data cloud really sits, right? You see not much data is really out here. A lot of the data is really in here. And if we didn't do that alpha, we get a lot of overplotting. It's not so easy to see where the data is, how many points are clustered in here. Okay? So that's what alpha is for. All right, so a couple things. I'm going to run through these slides much more quickly than the past. Some of them are just showing examples of how to do things. Some of them are examples of how not to do things. So sometimes, for example, I took the entire data set. This is the death data set. This is every single country plotted. Sometimes it's really hard to see. Right? This is a scatter plot. It exists. It is terrible. You're not going to be able to glean that much information on this unless you maybe do some alpha blending. But we colored it by country. The data equals all the data. We want to plot lines. Color equals false. I did this because if I did not do color equals false in the guides, it's going to print a legend with every single country in there. Right? So if you've used Stata before and you've done something where you colored by something and there's like 100 levels, you pretty much almost don't even see a plot. You just see a legend with 100 different things. Same thing in R. Okay? Tile. Geome tile is one way to do heat maps. There is a heat map function in R. We're not going to go over it, but it is, in a lot of respects, a better way to do heat maps. But sometimes you want to look at data where you have a rectangle that fills in some information. So, for example, here we have year, Y. Each one of these blobs is a different country. And then we want to map into the cell some sort of information about that. And this is the death, the mortality rate. So, again, X is year, Y is an individual country. So, countries are blocked off like this. Fill, we actually fill in that rectangle based on the mortality data. Geome equals tile, right? So there's just geome underscore tile function that if you're using ggplot functionality. Xlim, again, one way you can subset the data. Xlim was an argument in the plot function. Xlim is a function you can add to a ggplot. Okay, so just like xlab, ylab you add to it, you add xlim and it limits the data to the limits that you give it. So it says I only want to plot data from 1990 to 2005. Again, I don't need, this is actually irrelevant, but you see here that it makes a guide for fill that says 0 is really, really, really dark, 5 is pretty light blue, and you see there's not much good discrepancy here between the other countries because they have such low infant mortality. You can change the fill, not just manually. There are other functions. So if you do scale underscore, let's say fill, and hit tab, you'll see all the different ways you can specify a color for fill. Say scale underscore fill underscore gradient. The low is blue, the red is high. So instead of using the default Black is the lowest, blue is the highest. We could have said blue is low, red is high, and we'll do a continuum throughout that. Again, we don't see any good information up here because of how low the mortality is compared to these other countries. So let's say we use cut like we did before. Let's take the data and cut it into 4 different categories, 4 equally spaced categories. We could have used quantiles or anything like that. But I'm making a categorical variable, and I want to color those rectangles by that categorical variable. So again, we use the cut command. I'm going to cut the mortality data. It breaks 0, 1, 2, and then the max. So we have 4 breaks, 3 categories. And now I'm going to do plot, year, country. Fill is no longer the number of deaths. It's this categorical variable. And we want to use tiles again. And for some reason, that didn't plot. But that is a good thing to note. Because, one main thing. If you assign a plot to something, that by default does not plot. In ggplot, if you assign it out. It says you don't want to plot it yet. You just want to save it as something. In order to plot that, you either have to just write the command or write the object, or you explicitly have to say print. And then it'll print this out. So now we see here, this is the data. So there's not necessarily data for every single year. So that's missing, right? Like these countries don't have data up in here, right? Or it's not, sorry, it's not in this category. No, 2 things. What was one of the catches on cut? Not including the lowest. So I believe what happens here is they were dropped out. I have to double check that. But the idea is 0 to 1, right? We see that's the low category. High, 2.4 is blue. So we see really high infant mortality, almost similar infant mortality as these countries about, 50 years before that. And we see that the slow progression of blue to pink or salmon or red. If you're red or colorblind, I apologize. This palette is not for you, let's say. But you can see that this progression happens. And this type of tiling works really well when you're plotting a whole bunch of countries and you don't want that messy little that really messy scatter plot. So colors. It's really hard to make a good color palette. It's hard to make color palettes that sometimes are red-green colorblind that are also good at discrepancies. Google red-green colorblind palettes, and that should be one I would suggest you use. Using red and green as 2 plot types will at least exclude maybe 8 to 10% of your male population because they won't be able to discriminate between the colors. So our color brewer is a package that that gives you a set of palettes that are very helpful. So if you run R Color Brewer, again, you have to download and load this package if you want to use these functions. It will show you all the palettes available. You can print them out, keep next to your monitor for your convenience. Brewer.pal gives you an idea on how to use the package. If you click R Color Brewer 2, it should give you this map page, and it'll show you the different palettes. It'll tell you what the palette name is, and it'll show you kind of what it looks like on a map. If you want to change certain things, right? Say, oh, I like red and blues. Okay, maybe I want a diverging palette, so I want to go from like high to low, and you can click around on that, and the palette name, sorry, it's hard to see, is right here. It's RDYLBU, so it goes from red to blue. And let's say, and so those are the palettes that you can use. So it's a quick and pretty convenient way of defining your color palettes. It's a good package. I would just Google around for that. ggplot2 also allows you to use scale_fill_brewer. So you can use these palettes out of the box without having to define your own. So I want a diverging palette, and I want to use the red to blue. So this will go red, white, blue. So we'll show some discrepancies. Again, probably not the best thing. I chose white because of this projector, but on my screen, I see a difference between that and the background, but on here you can't. So I'm going to run through very quickly some of the things, some plots that you do a lot of times, stack bar charts. I don't do them that much, but a lot of people do. So if you make a table, like a 2x2 table, a two-way table, right? So in this case, we're doing is it a bad buy versus vehicle age. If you do that and you pass in this table to a bar plot, it will do a stacked bar plot for you. A lot of times you don't want to do that. You want to do a bar plot that is based on percentages, not raw counts. So if you use prop.table, like we talked about before, that does a table of proportions. In this case, we're doing column percentages. This is what you get out here. So this is 0 to 9 is the age of the car. And we see what proportion of that is a bad buy. So we see the older your car, the higher the probability you're going to, the higher proportion of cars that are a bad buy. Okay, so if you buy a brand new car, none of them happen to be a bad buy in this data set, but if you buy an 8-year-old car, maybe around 75% of them are bad, or a bad buy. Okay, so if you use a table and use the bar plot command, you can get a bar plot quickly. If you use prop.table on top of that, you can get this stack bar chart that gives you the breakdowns that a lot of people want usually in their trials. This is the way you do it with ggplot2. You pretty much use geom bar. The big difference between this and the bar plot command we use in base, in order to get that nice stacked percentage bar plot that you did before, more or less you have to make that data set yourself. You have to make it a data frame. You can't just pass in a nice little table. So here, what we did was we grouped it by, is it a bad buy, and the vehicle age. We ran tally, which again does a frequency count. And then we got the percentage. And then we have bad buy, age, and N. Right? And then we can, we calculated the percentage just by this N divided by the total N. So lastly, I will say something about this ungroup command. So if you group a data set, it is now grouped if you save it back out. If you want to do something differently or regroup the data, dropping groups, the ungroup command just throws out all groups that are in the data set. So if you wanted to summarize something and it's grouped, and then you want to take that summarized data set and you want to regroup it somehow else, you have to ungroup it first. So that's what we did here. We actually grouped it by, is it a bad buy, and vehicle age. Then we said throw out those groups, and then we just want to group by vehicle age. Because we want to take this N divided by the sum of N by the age, right? What we want to do is say, hey, I want the denominator to be total number of cars in this age of vehicle, whether it's a bad buy or not. If I didn't ungroup it, what it's going to do is it's going to keep grouping it by bad buy, which is not what we want to do. And if we did it, if we run this, every single value is going to be 1, because it's going to do all combinations, N divided by the sum of N, it's going to give you the same number. So 1, we grouped it, we ungrouped it, sorry, we grouped it by vehicle age and whether it was a bad buy, did all combinations to get the counts. We ungrouped it and grouped it only by vehicle age to get the percentages. We had to do this by hand before we passed it into ggplot2. It wasn't this convenient command where we made a prop.table. Okay, and then the last thing we say stat equals identity, which says plot just the percentages as they are. Don't try to do anything fancy with it. And this is the thing we get. We can flip these. We can flip the labels, flip the factors if we'd like, and it'll look like the other plot. So again, I don't use these that frequently, but we have gotten requests, and I have done some trials, some things like this where you do bar plots broken down by certain things. Again, this is the other way around. So before, we were calculating the percentages that a vehicle was a bad buy over all different years. We regrouped it and did it the other way to say, let's separate bad buy, and then let's look at the breakdown of the vehicle ages. Right? So it is a different regrouping. We ungrouped it and grouped it by, is it a bad buy? And now each of these represent within not bad buys, what is the percentage of the cars that are, for example, a year 3. Again, similarly to row percentages or column percentages, just doing different plots that represent that data. So again, HISTs, I don't know why we put that on there. We've already shown most of these things, again, just with different data sets. Again, if we want it, so this is just, for example, some chick weight, and I mean chicks isn't like, you know, chickens. I meant chick weight is a data set in R that has the data set of small chickens. And this is their trajectory of their weight over time on different doses and concentrations of the drug. And I'm glad that's recorded. So we put X as time, the weight. We color it by the different chickens, and we use this data set and we use the line. So this is actually just looking at the growth of all the chickens. But again, this is totally fine. It really allows you to see things, but it's not super great because that's way too many things in a plot or in a legend. Or that's kind of the extent. That's probably the max. Like probably over 30 is like way too many. It's really hard to differentiate things. On top of this, again, we can color things and we can still use facets. So in this case, we faceted them by the 4 different diets they were on. We still have the mapping of what ID they were, but again, we look at the growth charts just by different facets. And then if we want to just remove, again, the colors, what this aesthetic is mapped to, color chick, color equals false, we're going to say we want to remove that legend for that variable. Yeah. So we showed. I'm gonna breeze over those really quickly. All right, I'm not cover those. After this, there's base graphics in the lecture notes. I'm not gonna cover them because I think we covered a lot of them in ggplot. Plus, the syntax is completely different. One thing that is not in the notes that I think is super fun that we are not going to cover, but I think it's super fun, so I think you definitely need to see it so you can razzle dazzle all your colleagues. Is errors? No. Let's see. What was that one that we wanted to show? The plots. Okay, so by chick weight. I want to do lines. Nope, don't care about that one. Okay, I wanted to color it by the different chicks. There we go. Trust me, this will be worth it. And I want to do guides, color equals false. Okay? So, this is a package you have to download. It's called Plotly. Plot-L-Y. Okay? The reason I think it's awesome, so we have this ggplot2 object, G. Right? We just taught you how to build it. You say ggplotly on this object. Let me see if it worked. Nope. So, you should probably listen to it. It says install the development version. I will install that really quickly. So what this will do is it'll give you an interactive graphic. Okay. Let me redefine this. I need to restart my R session really quickly. Because when you install a package that you already have loaded, things can go a little bit weird. I want to assign this to G. Plotly.
you added plotly, the code that you have up in the constant
Sorry, the code to actually make the.
because that's the original data GB plot that you invert. Where is that? Is that in anything that we have?
Yes, that is. So if you go to the website, all right, I'll send out a code that actually works. That one didn't. But Plotly is a way to make things interactive. So if you go to visualization, and you say R, that's the R code for all the slides.
Oh,
All right. Well, didn't get to that. I'll send out something that actually does work, so you can actually see it work. It could be the versions I have on here. So what we're going to do is move on to statistics, because that is important. Okay. And then we're going to go do a lab with that. So, okay. We're not going to go over some of the, some advanced statistics, some linear mixed models. There are packages to do all those things. We're going to cover the standard things, I would say, right? Correlation, t-tests, or rank sum tests. Linear regression, logistic regression, test of proportion, chi-square test, and physics exact test. Okay? If you have a burning desire and say, I want to know how to do this, ask it now. Or ask it at the end of this, and I'll say, look at this package. Okay? Anywhere throughout, you can ask it. It's fine. We're not going to cover the methods, the theory, or when you should use these things. That is for a statistics course. Okay? You should. So if you don't know which test to use, consult your neighborly statistician or the internet or your textbooks. Okay? We're just going to show you how to do things, right? Whether that be dangerous or not. All right. So CORE, C-O-R, calculates correlations, right? So if there are NAs, you get NA as the result, but if you specify to use only the complete observations, you will get a correlation of the non-missing data, right? So if you look at the options for CORE in the help file, because there are multiple things. There are multiple different ways you can calculate a correlation based with missing data in that, okay? Because remember, it is the covariance of x and y divided by the covariance divided by the standard deviation of x and the standard deviation of y. You can calculate those standard deviations of x and y with all the data that's not missing in x and all the data that's not missing in y, the data that's not missing in both of them. So those denominators can be very different depending on how you select the data. Okay? So, also, you can do the different types of correlation. Pearson, Spearman, Kendall. Okay? So that should give you Kendall's tau or Spearman's rho. Okay. So we're reading the data set in. So again, this takes x and y. Circular data set. We're going to use the complete observation. Anything's missing in either one of these, throw it out. Correlation between the orange line average and the purple line average. So do they correlate together? Or do people take, if people are taking the orange, are they not taking the purple, for example? 0.91. That's what you get out. Doesn't do a test. Just gives you a correlation. CORE just does an estimate. Okay? If you give it a matrix rather than an x and a y vector, it will give you a correlation matrix back. Okay? So here, we selected the columns that end in average. Okay? Orange, purple, green, banner, average. We passed that into the CORE function. It gives us a correlation matrix. Boom, everything on the diagonal should be 1. Everything is 100% correlated with itself. And the off diagonals are giving you the correlation. So the correlation between orange and purple is 0.908. Green and orange is 0.84. So again, you should note, this is not the same number. This is 0.91. This is 0.908. Because it's not just complete observations between those two, it's the complete observations overall. So this number was not the same number that we had in the last example because there are different subsets going on here because of the way the subsetting is done with missing data. Yes?
is there any way to get out the ends and p-values?
Not with the CORE function. So,
And these are all zero order.
zero order.
They're not partial.
They're not partial. You have to do the
Regression.
you have to get a partial correlation, you invert the matrix.
Okay.
Yes. Core.test is what you want, yes.
If you were doing this with data that required weight design variables, how would they be put into
No, I don't know that. I don't do that. You probably would use the survey package.
You have to use it, okay.
It's a different package because it does a different weighting scheme. That's a good question. I don't know the answer to. Core.test. Test the correlations. Okay. So whether you test whether it's significant, linear regression may be better if you want to regress out other confounders, but here you're just putting in two vectors. Again, it'll have the same arguments with respect to use. So it gives you, so core.test gives you this output. So we assign it to this thing called CT. Right? I just felt like calling it CT for core test. Right? We put in two separate vectors. We say do the complete observations. This is what we get. So it says we're doing a Pearson correlation. This is the data was put in here. This is the t-statistic, the degrees of freedom. This is the p-value associated with the correlation being 0. Alternative hypothesis, again, it's just letting you know what it is. 95% confidence interval on the correlation and the estimate of the correlation itself. Okay. So all those things are stored in that object. So the things stored in that object are the statistic, the parameter, the p-value, the estimate, the null value, the alternative, the method, the data name, and the confidence interval. So these types of objects, we are going to show you, they're kind of like lists. You can grab the things with the $sign. So CT $sign statistic gives you the t statistic. Parameter will give you the degrees of freedom. CT $sign p-value gives you the p-value back. Now when it's super, super small, it will say something is 0. As a statistician, I want to tell you, p-values are never 0. Never. You never put p equals 0. That doesn't make any sense. Because it is a probability of seeing something as extreme or more extreme than what you saw. You saw it. So it can't be 0. Okay? It's less than some sort of threshold. That's how you present it. P equals 0. Anytime I see that in a paper, the red pen's coming out. Rant over. So, okay. There's a package. So the thing about those tests is it's great. But sometimes they're not. Like we taught you how to do things in dplyr. We taught you how to manipulate data with respect to data frames. Right? Having these other components where you have to use $signs and all that kind of stuff, it's kind of not great. And it's not consistent by the way we're teaching. There is a package called Broom. It is by this guy Dave Robinson, who's also a very, very good R developer. Sadly, though, he said, so he has a twin brother. When he was developing the package, he's like, I want a package called Broom because I want to clean things up. What should I call the main function in there? And he says, well, you want to clean things up. So his brother said you should tidy things up, and he chose that function name, and it's a great function name, but the problem is there is a tidy R package. The tidy function is not in there. It is in the Broom package. So, tidy R is made by Hadley. Broom is made by David. So, they didn't necessarily talk to each other, and he says, we've spoken at conferences, he says he regrets making that name, but it's stuck, that's the way it is. So, tidy will take outputs of tests or models and put them into data frames in a usable way. So again, CT $sign statistic is fine. But if you say tidy on that object, tidy, it'll give it back into a data frame. And so let's say you do a bunch of these tests and you tidy them up and then you start R-binding them together. Now you have a data frame which has estimates, statistics, p-values, and that kind of stuff. And then if you put them together and start merging them or R-binding them together, now you have a data frame that has statistics from the tests you want that you know how to operate on with dplyr. So tidy makes them into formats that are more usable. Granted, this is only a data frame with one row. That's not that great. That's not that useful. Why don't I just use a $sign? Total reasonable response. When we get to models, it makes things a lot better because you won't just have one row, you'll have multiple rows. So in ggplot2, I would highly suggest looking at the annotate function, ANNOTATE, annotate. That allows you to annotate plots very easily, to place text on them. Text or legend is a function in R that allows you to put text in here. This is in base R, so this is plotting the orange versus the purple line with the scatter plot, and we just show you a way to get the estimate, which is the correlation, round it to a few decimals, and put it on top of here. I would use if you're using ggplot2, I would use the annotate function, but this is a way you can get data and put it on a plot, a scatter plot. So I wish I had known this slide was next, which I didn't. So that's base. This is the way you do it for ggplot. Plot the data, annotate. You say you want text, and you say what is the text that you want to add in there. Text, we grabbed R equals signif is a function that will round data to some sort of significant digits. In this case, 3 significant digits. So we say there's a signif and there's a round function. Rounds things to a certain number of digits. And so we say we want to put it on 4,000 and 8,000, and we want the size to be, 5. So that's how we can add that to the plot. T.test. Different syntax than core.test, but the outputs are very similar. So T.test, you can give it 2 vectors. Orange average, purple average. Gets means, standard deviations. Note, if you don't tell it it's paired, it's not a paired test. It does a 2-sample t-test. And it'll tell you right here. That is the output. Well, it's just 2-sample t-test, gives you degrees of freedom. Mean of x, mean of y. First one's x, second one's y. It gives you a 95% confidence interval and a difference in the means. And it does the mean of x minus the mean of y. As you can note, because these are negative, the mean of x is less than y. Okay. Again, if we look at the names, very, very similar, consistent with what core.test gives you back. Statistics, estimates, confidence intervals, all that fun stuff. Again, you can tidy it up. It tells you what test it is. It tells you the confidence interval. It tells you the estimate. Estimate 1 is the mean for x. Estimate 2 is the mean for y. This t-statistic, the p-value. Parameter. Parameter, in this case, is the degrees of freedom. Right? Pretty much, that is almost essentially 0, but you would not, again, present it to be 0. That is 61 zeros. You can't, your computer can't even store a number that has that many digits in it. So that is one way you specify a t-test. That is if your data is wide. That's if you have column A and column B, and you say, okay, I want you to do a t-test. There is an option on t.test that says paired equals false or paired equals true. If you say it's equal to true, the 2 vectors you put in there have to be the same length, and they're matched up together. Okay? There's another way you do t.test. Okay? We are going to reshape the data. We only selected the orange average and the purple average, and we gathered it up together so that the data is now orange, purple. Sorry, orange and purple together with the same dates. It's just in a long format. But now it is mapped so that the line variable is either purple average or orange average. Right? So you say average tilde line, data equals long. So it's y tilde x. Y is the actual thing you want to test on. X is a 2-factor variable. Thing with only 2 categories. If you have more than 1 category, you can't do a t-test. That's not what t-test does. It only takes 2 means, standard deviations. Again, we're not treating this data as paired. We didn't say paired equals true. It doesn't think that. That's why, again, it says, well, it's just 2-sample t-test. It gives you the exact same output after we tidied it up. Now, t-test, test some means. Wilcox.test, rank some tests, test some means. Okay? Usually you use it. Usually you use this. It does a different test, but a lot of times with smaller sample sizes, or if you have data that's not very symmetric or highly skewed, or if you just want to do a rank-based test. So Wilcox.test. Again, we use the same syntax. Things we want with respect to the line, the number of people on there, tilde, line, where it's the 2 factors, and we say this is the statistic. This is the statistic. This is a W statistic in the Wilcox.test. This is the p-value. It doesn't, for some reason, I don't think in this one give you the degrees of freedom. There should be a degrees of freedom. It compares it to a chi-square distribution with a certain degrees of freedom. So if you want to do more than 2 cases for a t-test, you have to do it in an ANOVA or linear regression. If you want to do more than 2 categories for a Wilcox, a rank-based test, you have to use the Kruskal-Wallis test, which is Kruskal.test. K-R-U-S-K-A-L. Kruskal.test. All right, let's go to the lab. So we got correlation test, t-test, and tidy. Note, you have to install Broom if you want to use tidy. Okay? Let's go to the lab.
There's no lab.
Nope. Did you put the lab? Sorry. Ah, okay. Sorry about that. Did you? Well, let's take a break then. Where's the? Oh, yeah. It's looking for it in a specific folder. So refresh your web page like 15 times and it should be there. So it takes a minute for the website to update. All right, if you go to the website, Stat Lab should be up there with the key. So let's move on to that. Why are you so small? There we go. I'll be back. All right. Let's go over some stats. Compute the correlation between 1980, 1990, 2000, 2010. No need to save. This is an object. So, leave the mortality data in there. If we just try core on mort, it says no, x must be numeric. So we can say select mort. Let's do mort. Let's do some piping. So note, in order to do this with select, you got to put these funky little backticks around it. I think it will. I'm not 100% sure. Yeah. You can put quotes. If you do that, and then core, it says up, getting an A. And again, core doesn't have an na.rm, but if you say complete.obs, it would do the correlation for the complete observation. Essentially, you just complete.cases. Now, to the question before, Yes, there is a function that will do correlation tests on a matrix. But it is in the psych package. So you have to install and download that package. And by default, it will give you these fun correlations, the sample sizes, and the p-values. But to note, adjusted for multiple tests by default. It does a correction. It's not Bonferroni. And the name of that function is core.test, but it's not the 1R test that you know and love. It's the double R. So core is in correlation. 2 R's, that is in the psych package, and that'll allow you to do multiple correlation tests at once. And let's look at the help file. You can see it does pairwise, it does Pearson adjustment, it does a p-value adjustment based on Holmes' method. But if we say adjust equals none, it gives us p-values, and it doesn't do any adjustment on the sample sizes in here. So it gives us the tests, the sample sizes, and all that kind of stuff. But if you just want to get an estimate of the correlations, again, you have to be specific as to, you have to be, well, careful as to what data you're using. Because if we look at the information on core, it says use, you can either use everything, all observations, complete observations, NA or complete, or pairwise complete observations. Pairwise complete observations is probably what you would assume in some respects, right? So all the cells of that correlation table that we're doing at the top have the same sample size in there. If you use pairwise complete observations, they will have different sample sizes. Okay. The backticks. The backticks are for variables that have spaces, or they don't conform to kind of the column name specification for a data frame. One of those things is kind of like, so it's very similar with variable names. You can't start a variable name with, you can have a special character in there. You can't have hyphens. You can't have dollar signs. You can't have quotes in there. You also cannot start a variable name with a number. That's why these have these little backticks, because they're column names that begin with a number. That's why they have to be quoted. Good question, though.
So the way I had thought to do this was not to type it, but to put the dollar signs, like the name of the dollar each column.
So you can do that, but then you have to write core, for example, mort.
Yeah, I did.
Nights. It didn't work. So you have to. You still have to. You have to do the backticks. You can also do it where you say mort, 1980, for example, 1990, 2010. You could use the different type of syntax for subsetting. This is the base way, the bracket way. If you select, you have to use quotes or backticks to grab them out because they're special. So let's compute the correlation between Myanmar, China, US mortality data, store this correlation matrix in an object called country core, extract the Myanmar US correlation from the correlation matrix. So again, we could have used the select or the other way, but here we are just going to filter because we want to subset the data based on the rows. What we're going to do is take the data, filter country within the ones we just specified, and then we're going to say select, drop country. We want all the other years. We want all the years of the data. Now, we have this. Yep.
I don't understand the last select part.
The select part?
Yeah, the minus the negative country.
So negative country, so when you say select and a variable name, it says keep that one. If you say select with a negative out in front, it says remove that one. everything but that one. Okay? So now it's got every single column, but the first column is no longer country. We removed it. So, if we do core on mort subs, it gives us a very, very, very big correlation matrix. That's because it's doing the correlation over every single column of each other. Right? We don't want that. We want a, US, Myanmar, Myanmar, China, China, United States correlation. So we have to transpose the data so that the rows are the columns, and the columns become the rows. So if I say tmort, transpose, so the t function transposes data. So if I say we filtered out country. Let me do this first. Just say this.
There was some kind of transpose function you told us never to use.
There's a reshape function.
Okay.
Don't use it.
Okay.
Yeah. T will transpose the data though.
Completely.
Transpose the data completely. Oh. Mort subs, before we drop the country, the first row is China, the second one is Myanmar, the third one is the United States. If we transpose this guy, the first column is China, the second column is Myanmar, and the third column is United States. But again, we don't want that country level information in there, so we transpose the data, but we selected out the rows first, because when we go to transpose this data, this is character. It's going to assume this column is now a character, which is what we don't want. We don't want that to happen. So we say, get rid of that country, transpose the data in here. So let's pull this out. Transpose the data, give me a correlation. Now it's a 3 by 3. So first one is China, second is Myanmar, third one's US. So this one is China, Myanmar, Myanmar, US, China, US. So it's the correlation over all time that we have data for the complete observation. So when we have data on child mortality at China and US and Myanmar at the same time. That is the correlation matrix between the three. And then if we want to extract the Myanmar US, that is either the first column, the third row, but because it's a correlation matrix, it is symmetric. It is either the first column, third row, or the third row, first column. Oh, yeah. Okay. So by default, core will assume you want to do the correlation between columns. So if you have data in a way where that's not the case, you either have to reshape it or you have to do transpose. Okay. Core.test with 2 R's will do the correlation test on an entire matrix. And you can, but by default, it does p-value adjustments, which is usually not always what you want to do. So, is there a difference between mortality information from 1990 and 2000? Run a t-test and a Wilcoxon rank sum test to assess this. So, we are grabbing the 1990 column and the 2000 column. Okay. So, that is one way you can do it. We could use the dollar signs and the backticks. show you. They give you the exact same things out. 2-sample t-test. But what would we probably want to do? Probably want to say it's paired, because each row is the same country, right? This is paired data. So the same data from country A at 1990 and 2000. So this is a 2-sample t-test treating 1990 data and 2000 data as completely independent samples, right? So it's testing whether the mean of A is equal to the mean of B. That's why you get 2 separate estimates. That's why you get a confidence interval of the difference and a p-value and specific degrees of freedom. If you say paired equals true, it is a different test altogether. It does the differences and then does 1-sample t-test on the differences. That's why it only gives you a mean of the difference. That is the only statistic that matters. You could have by hand taken this data and subtracted off this data. Note there's also not, if you don't have data at both of those, so let's say you had data for a country in 2000 but not 1990, that country is not going to go into the calculation. We don't know the difference of the measures of those times. So p-value is very different, degrees of freedom are very different, t-statistics very different, test is different. Okay? Not the same thing. But nobody here has correlated data, so it's fine. Right? Okay. So the paired argument in t.test does paired t-test. Core.test, the core.test with 1R does correlation tests, but it only takes 1 vector in, or 2 vectors in at a time, and there is no such thing as a paired correlation test, right? That's what you're doing. You're trying to see the correlation between the two things. And it's testing whether it's 0 or not. You can put in a different alternative. It's by default a 2-sided test. All these are arguments you can look up in the function to see things you can change, and you can use tidy to tidy these things up into a data frame so that you can do fun things with dplyr. Linear regression. So linear regression, right? Y is a function of some sort of x variables. Simple linear regression. You have an alpha, that's an intercept. Beta, that's the slope. X sub I is the observation or the predictor for subject I or record I, and you have some residual noise, which is assumed to be normal. So Y is the outcome, alpha is the intercept, beta is the slope, X is some sort of predictor, residual variance. It's assumed to be mean 0. Also, some of the assumptions are that the residuals are orthogonal to the predictors after you regress them out. Okay, at least linearly. So R, the formula syntax we have been talking about. It's called the formula syntax because it started with the formula of an equation. Formulas for regressions. So it's y tilde x. So a simple linear regression, y is an actual variable in your data set, x is an actual variable in your data set. If you named y to be like outcome, you would put outcome in there. You don't actually just put y. So in this case, we have our long data, and we want to do a linear regression on whether average is different based on the line. Again, this may not be, and actually isn't, that appropriate of a model, right? Because we know that data is correlated. But this will give you, if there's only 2 lines, the exact same output as a t-test. If it's a binary predictor on the right-hand side. So LM is the function of the day that we're using, linear model. So we do the formula syntax, we specify the data set we're using, and then this is what we get out. So it says the call. What did you actually call to this data set? Coefficients, intercept, so this is beta 0 or alpha in your data. Line purple average, that is beta or beta 1, depending on what you're doing. But in a simple linear regression, the way we specify it, just beta, it's just the slope. So this is saying that the mean difference between the purple average and the orange average, looking at all the days in the data, is about 983 riders. The average for the orange line is 3,033. There are ways to do linear combinations and all this kind of stuff, but this doesn't give you t-statistics or any of that kind of stuff yet. This is just the output that it gives you. Note also what it gives you with factors. This is a factor. Even if it's a character in your data set, it will happen, like the plotting functions, it'll make it into a factor, and then it will give you, it will make it into a factor and then run the regression.
Is that an unstandardized estimate?
Excuse me?
Is that an unstandardized estimate? I know there's only one thing in the model right now.
Totally understand. Unstandardized. So, the summary command, we used that before on data sets, and it shows the quantile. It's not super useful for data frames, for example. It shows you the quantiles, the mean. Not so great. But when you do summary on a linear model object, okay, it gives you the statistics and p-values and all that kind of stuff that you want. It also gives you this, I have no idea, it gives you this residual, like a description of the residuals, the distribution of them. I think the idea is to see, like, you know, is it symmetric? I find it very hard to see based on like 5 numbers if a distribution is symmetric. I would just plot the residuals. So there is a residuals function to extract those. But it gives you the estimate, the standard error, the t-statistic, and the probability that the t, it's a 2-sided test for that t-statistic, and it gives you the p-value associated with that. By default, it puts these significant codes on there. Don't use them. Always look at the coefficients, the things that are important. We're not going to get into the things about p-values and all that kind of stuff. I'm sure your local statistician would love to talk your ear off about that. But p-values aren't the only name in the game. It also talks about the residual standard error, the degrees of freedom, the multiple R squared. It also tells you some of the things are deleted due to missing this. This is also important. So, sorry, let's go back. You can assign, so the model itself does not have these estimates and all that fun stuff in there. The summary of that model does. That being said, when you want to do predictions, when you want to look at residuals, stuff like that, you operate on the original model. When you want to get the coefficient tables with the t-statistics, you operate on the summary of that. Tidy will help you out, and I'll show you in a minute. So the names of the summaries, right? So it's the call, the adjusted R squared, the S statistic, the sigma, the residuals, degrees of freedom, covariance, unscaled, the coefficients. Coefficients is really what you want, R squared and NA dot action. So coefficients in the summary of the data, summary of the model, isn't just the coefficients. It's the coefficients and the t-statistics and the standard errors. Tidy, if you throw tidy onto the original model, this is what it will give you. It'll give you a data frame where it says the term, the estimate, standard error, statistic, and p-value. Now, I want to contrast this and this. This is a matrix. Row names. These are the row names. These are not a column, right? Again, not the best behavior. Second, do these look like fun columns to work with after what we just talked about having spaces and that kind of stuff in your column names for data sets? No. They have spaces. They have greater than signs. They have pipes. They have parentheses. They have periods and spaces. They have different cases. Tidies it up. These are all lowercase. These are all columns of a data frame. These all don't have spaces. So you can grab them the same way you would any other data frame. So that's why tidy is very useful. So it takes it, grabs the standard errors, but again, you put it on the original object, the original model, and it'll give you this table, and then you can start making, you can output this to a CSV, you can start, calculating whatever you want from this.
Can you use that to, like if you made a plot and you wanted to add standard error to, would you pull it from here?
Yes. So for example, let's say you have like 10 coefficients.
Okay.
You can grab them. Now this is a data frame. You can throw it in a ggplot, for example, plot, estimate, and standard error.
Okay.
I will say it's not like, error bar plot. There are ways to make error bars, but it's not just, throw a model in. So you can plot a model specifically. So you can put, on a model, you can say plot, and it'll do a series of plots. So it'll do a residual plot, it'll do a leverage plot, and those kind of things that you can scroll through to see some checks to see how good the assumptions of the model kind of hold.
Okay.
But if you're talking about like reporting estimates and standard errors, yeah, you would go this way. Yes?
So the model determine automatically the factor, the variable is a factor, or we have to specify?
So if you put in a numeric variable that's binary, right? If I said line type is 0 for purple, 1 for orange, let's say, and I put that into a model, and it's a numeric, it's just going to treat it as a number, right? If it's a numeric. If it's a character or already a factor, it'll coerce characters to factors, and it'll use or it'll just use the factors. The big difference between if you put it in as a character or putting it as a factor is two. One, you specify the levels, right? That's the biggest thing, is that you have already been able to specify the levels if you made the factor yourself. Second, it will do a category for every single level of that character vector, which might not be the case, might not be what you want. And it will do, it's not the best naming convention, but the way it does is it said, this is the name of the variable joined with the actual factor itself. The level itself, so line purple average. If we had a green average, it would say line green average, for example.
So the reference level is automatically determined by how you change.
If you've created a factor and set the levels yourself, it is whatever the baseline level is, whatever the first level of that factor is. In this case, I didn't do that. I didn't set that, so O comes before P, right? So orange was set as the baseline level. Does that make sense?
Okay, that means you have to always put there your baseline as the first level, or you specify it?
Not in the model. You change the variable in your data set. You say factor, variable name, and then you specify the levels to whatever order you want. But the most important ones are what is the first one, because all the interpretability of the coefficients is based on what the first level is. Okay. We're reading in some of the cars data here. This is a more appropriate model. All that other data, you probably want to use either a GEE model. So there's a GEESE or GEES package. GEE pack is a package for GEs as well. LME4. I don't know why it's the number 4. LME stands for linear mixed effects. Right, so LME4 package will allow you to do linear mixed effects models. But here, for example, let's see if the vehicle odometer is different by the vehicle age. So vehicle age in this data set is a numeric, right? It's 0 to 9, the age of the vehicle. So if we do not separate it as a factor, we put it in a numeric variable, it will treat it as a number, right? So we're assuming this relationship is linear. So the odometer age. So that's why it only gives us one coefficient. Okay? Does this make sense? Saw something on the next slide I'm not going to like. I didn't make that slide, so I'm going to at least just throw a scapegoat out there because Andrew's not here. He made this slide because I think that is terrible. Right here. No. Don't do that. T is not 0. No. So this is plotting the age against the vehicle odometer. So that is the age, that's the vehicle odometer. AB line, if you put AB line for, A is the intercept, B is the slope. AB line, if you put a model object into that, this is in base, it will plot the line. Right? Also, we can put the p-values. We did here we did box plots to show the median over time. Not the mean. We might want to put the points of the mean in here as well. But pretty much it's saying, okay, how linear is this relationship for the most part? I'm jumping over to this slide because it's done in ggplot too, so I think it might be a little bit easier to see. So again, ggplot Y is the odometer, X is the age, this is the car data set. I'm just doing some jittering so that I don't overplot everything on one straight line on the age. Again, I want the height to be 0. Don't change anything about this. Change only the sizes of this. Alpha is 0.05. So again, there's a lot of overplotting going on here. Alpha blending will allow us to see where the true bolus of the data is. Here, it's really down here, and so on and so forth. Geom smooth. Geom smooth before will give us a smoother, but it does it with low S by default, depending on how many points there are. You can change the method for the smoothing. If you say method equals LM, that will do a smoother based on a linear model. That'll give you the line of the linear model fit, right? So SE equals false. SE is just the standard error. So by default, it'll do the standard errors of these plots. Sometimes they're appropriate, sometimes they are not. Especially when you have longitudinal repeated data, the standard errors are not correct. So this is the shape. This is what the fit looks like. Okay, now simple linear regression. Just put one variable in there. Makes the most. It's very simple with some of these things. But now we're starting getting multiple linear regression. So we put pluses between things. Is bad by is coded as 0 or 1 in the data set. It is not a character. It is not a factor. It is a numeric variable with zeros or ones. You can also specify indicator variables that way. You do not have to make them factors or anything like that. So we say y tilde x1 plus x2 in the data set. Okay? So now we have two regression coefficients. One is it a bad buy or not? The other one is age. So now this is the estimate, again, non-standardized coefficients for whether it's a bad buy, adjusted for vehicle age, and vice versa. Right? So the vehicle age adjusted for whether it's a bad buy or not. So really, coming back to this, sorry, if we did tidy on this, there'd be 3 rows in this data frame. Right? But same output, same thing. It's just adding lines. One way you can see about linearity, so there's a car package, right? And there's a function AV plots, so added variable plots, right? So sometimes you want to see the linearity of x and y. That's very important if you want to see, if the linear regression is appropriate. But when you start adjusting for multiple variables, you have to look at the linearity of that variable after adjusting for other variables. That's what an added variable plot can show you. So it's plotting the residuals of the odometer on the others, bad buy on the others. Binary data, it's not so simple, but this is looking at the vehicle age given. You've already regressed out the effect of bad buy, and the odometer regressed out the effect of bad buy. So sometimes, let's say, if you had 2 continuous variables, both of them might be linear, but they also might be highly correlated. And after you adjust for one, the relationship between that variable and y is no longer linear. It might be, curved or something like that. So added variable plots are really helpful to see that. And all you got to do is put in the variable into this function, and it'll print them out. So if you plot an if you say plot on an LM object, it'll do diagnostic plots. Residuals versus fitted should not have a discernible shape. There's a red line on there that is a smoother. QQ plot will show you how well the residual fit a normal distribution. Cook's distance measures the influence of individual points. So if I just say plot on fit 2, what will come up? It'll say, here's the first plot, click enter, and go to the next plot. So the first plot is the residuals versus the fitted. The next is a QQ plot. The third is a scale versus location. And then the other one is residuals versus leverage. So I'm going to do that in let me read in the cars data set and actually do this plot. Okay. Okay, fit 2, plot, fit 2. It's going to say hit enter, go to the next plot. Sorry. MF row. Why is this holding like that? Of course, I closed it. So these are scales versus the residuals. So these are the fitted values on the x-axis, the residuals. So these shouldn't really have any discernible shape. There might be some curvature here, but it doesn't necessarily seem like it should be. It should be a relatively flat line. The average of all of these, by definition, is 0. The average of the residuals. So looking to see whether the average is 0 is not a very helpful technique. This is the QQ plot. So it's a quantile plot. So residuals versus the standardized residuals compared to a normal. You can't see it. There's a dotted line here. And if it falls on that, the data maps pretty well to a normal distribution. There seems to be maybe some heavy tails over here. So it might seem to be, it might seem to indicate not so great lack of fit in one of the tails. The way we look, when we looked at those added variable, or sorry, when we looked at those histograms, nope, not that word. When we looked at the scatter plots, this scatter plot, we see that the fit doesn't probably necessarily do too well when the data is really not an old car. It seems to fit probably okay over here, but again, when we looked at the data with these types of plots, it seems like when the data is really, really, a 1-year-old car, the model's not too great of a fit. Might want to think about a spline. There's a splines package for that. But that's kind of the plots you get when you plot an LM object, residuals versus fitted, to see if there's any sort of shape or heteroscedasticity, right? One of the most confusing words in all of statistics to say and what it is. So just saying, is the variance the same across levels of X or the fitted values? Right? Normal QQ, just to see if there's any normality. And then these two plots really help you identify some leverage points.
What does the first line say? Does it do?
What does this do? Par MF row. So we like in facets, you can do multiple subplots. In base, when you want instead of having a plot come up and go to the next one, if you wanted to do multiple panels, so MF row is a way to specify in base that you want it to be so there'd be 2 rows and 2 columns, and when you start plotting, it fills them in that way. Just a way of doing that. Putting in multiple things together in base. Good question. So you can define factors on the fly. Again, if you do put a character in there, it will make it a factor. But you can put a factor around the object. That being said, it does do some weird things with the naming of the variables, right? So it sees factor, for, GM, null, other. If I saw something like this, and somebody gave me a regression like this, first things I would say is you probably didn't clean your data, right? Null being there, probably not an actual type of a car. Probably don't know. It's probably missing, right? So I'd say that regression doesn't really mean much to me. Go back and clean your data. But again, you can define factors on the fly. But if you want p-values and all that kind of stuff, use the summary command. Okay, LM, linear models. GLM, generalized linear models. The big difference between LM and GLM is you specify the family. So the families are types of regressions. Binomial for logistic. Poisson for Poisson regression. Quasi-Poisson for quasi-Poisson regression. Negative binomial, n binomial. So if you do question mark family, before all these plots go through, family, binomial, Gaussian, gamma, inverse Gaussian, Poisson, quasi-binomial, quasi-Poisson. Okay. There are ways to do negative binomials and other things like that. You have to download add-on packages. There is an mlogit package for multinomial logistic regression. There is not, to my knowledge, a built-in one for R. I find that strange, but that's the way it is. There's multiple ways to do like the optimization for that. I don't exactly know why that is. So you can run a linear map, generalized linear model. So here we should have a 0, 1 variable. Okay. We say the family's binomial. We say these are two factors that we put in there. By default, the estimates will be on the scale of the data. These are log odds or log odds ratios. There is no option to say OR, like in Stata, to give you odds ratios. You have to use X yourself. There are ways to access that, but you just exponentiate the coefficients. But in order to do confidence intervals and all that kind of stuff, you should always work with the original scale. Okay? You do confidence intervals, all that kind of stuff in the original scale, and then exponentiate it or transform it back. Okay?
How do they do that?
Because GLM is a generic function.
Yeah, but it wouldn't be that hard to write exponentially.
But our programs just do it. That's what we do. I mean, we're used to that. Sometimes we want to present log odds. Sometimes we want to do changing behavior over 20 of a function that's worked for 20 years is a hard sell to the programmers that make R, especially because they do it on their free time for free. So there are packages that'll do the things you want, but I'm just saying the GLM package by default won't. But I'm saying there's no argument in here that'll say give me odds ratios. Okay, tidy. Tidy will tidy it up. But again, it'll be on the original scale. It's also a generic thing, right? There's not a logistic regression, binomial regression, Poisson regression the same way. It's generalized. It'll do it for any family. So the inversion's not always the same. Yes, it can be done. It can be done relatively straightforward. But that's not the way it is. The p-values will be the same, but again, you should always be working on the original scale, not the original scale, on the scale that it comes out. Right? You should work on the log odd scale to do confidence intervals and stuff like that because they have better asymptotic properties and all that kind of stuff, and then invert back to the original data. That's one of the properties of generalized linear models. So, coef gives you the coefficients. X, we're exponentiating them. These are either odds or odds ratios. Right? Again, also, scale your data to something that's meaningful. This is saying a 1 mile increases the probability of a bad buy by this. You should probably divide that number by 10,000 or something like that. So a 1 unit increase is saying add 10,000 miles to your car, something like that. So when you get stuff out, make sure they're kind of interpretable. All right, prompt.test. So that
That's a summary. So X summary will give you
X summary, no. It will exponentiate this table. Sorry, this table. So everything will be exponentiated. Right? X is just exponentiation. So it'll exponentiate the p-values, everything in that matrix.
So wait, what's the problem with that?
There's no problem with it per se, but that doesn't make sense for these. I mean, it's fine to get them out, but an exponentiated standard error is not
Oh,
correct.
no, of course.
No, there's no problem with it. Sorry. There's no problem with doing that. I'm just saying the other things that are exponentiated are not useful anymore, or they're not the things you want. All right, prof.test. Test of proportions. Sometimes you can put X and N in there. Most times you don't do it this way. You're going to put it in a table, but this is one way you can do it, saying how many outcomes out of the whole sample size. Again, gives you a very similar output to core.test and t.test. What is the test? What is the p-value? All that kind of stuff. Most of the time, you put in a table because you're doing a test of proportions across certain levels. So tab or table, we'll do the tables that we had done before. Chi-square.test, we'll do a test of independence across the rows and the columns. That is equivalent to a proportion test when the table is 2 by 2. Okay, so chi-squared.test will give you the test that you want. Again, an x and a y, whether you want to do corrections, or what you really do is you put in the entire table. That's what you commonly do. You create a table of x versus y, you put that table in a chi-squared.test, and it gives you a chi-squared test of independence, the chi-squared value, the degrees of freedom, and the p-value. Again, the output is very similar to the other things, the core.test and t.test, which means you can tidy it up. And this is showing for a 2x2 table for something that it has two factors, two levels for x and y. It's the same exact thing as prop.test. Right? So generally, what you do is, I think I've lost that. So, okay. Chi-squared.test, you put it on a table object. Fisher.test, same syntax more or less. You put in a table, and it'll do a Fisher's exact test for count data. Thank you very much. It will, if it's a 2x2 table, thank you. It'll give you an odds ratio and a confidence interval on that. If it is greater than 2x2, it will not give you that because it's not defined. But also, if you have really high cell counts, you might get some sort of error that says can't calculate that many iterations or something like that because it is a permutation-based test. There's a lot of computational burden going in there. If there's a lot of cells, you can try to up this workspace variable. But if you have a lot of things in your cells, if you have a large number of counts, you can usually go to a chi-square test and be okay. That should worry you though most of the time, because a lot of times the reason that happens is because you forgot to you either passed in something with a huge number of cells, like 20 by 20 matrix. You'll probably get some sort of error there, but that's probably not the test you want to do. Okay, so we're going to go to the lab for about 10 minutes. So the second part, Leslie and I will be walking around. And lastly, actually, we've covered pretty much everything other than that. These are some other things to use to say if you have a chi-squared test, this is one way you can get a p-value. You can look at those. R norm will give you random normal data. R binom will give you random binomial data, but a lot of times that's not being used as much. Sample is useful if you want to sample on a vector. Sometimes you want to sample the rows of a vector, for example, or sample the indices, and you want to do a subset. Sample, if you just run it on a sequence, it'll just do, without any other options, it'll do a permutation. But for the most part, we're just going to do the rest of the lab now because I want to talk about, for 2 minutes, final project and go over the homework 3 after the lab. So let's spend 10 minutes on the lab. Leslie and I will roam around. We'll very briefly talk about the project, go over the homework really quickly, and then wrap up. I did not talk, yeah, we will talk about those very briefly. Good question then. The lab. So there's interactions in the lab.
Oh, sorry.
Yes.
I just wanted to look through.
Yeah. So interactions. You do the star. You multiply things together. So this times this, it'll give you what you expect out in the sense of a main effect for this, a main effect for this, and the interaction between the two. Also, conf, C-O-N-F-I-N-T, conf int. will give you confidence intervals. Okay? There is confidence intervals, and in the TidyR package, there's confint underscore tiny or tidy, which will give you confidence intervals for model coefficients. Okay, so for example, if you say tidy fit 2, and you C-bind it together, this is one way you can get the data, get a confidence interval, put them together, now you have a confidence interval with the estimates together. And then you can start pasting these together using unite or something like that. You can round these things down using the round function or something like that, and start getting getting estimate outputs. Does that make sense? So tidy gets it in a nice little data frame. Confint on its own will give you a confidence interval estimate. Confint tidy will give you it in a data frame format that you can use a little bit better because the column names of confint are 2.5%, 97.5%, which is great to see, but it's not really great, again, for column names. So if you C-bind these two together, the estimate table and the confidence intervals, then you get kind of all the things you really need for most regression tables for analyses. And again, this is the confidence interval for the main effect, the other main effect, and the interaction. Also note, in the key, we do vehicle age times size, and we also do vehicle age plus size with the interaction. R understands that multiplication says do the interaction plus the main effects. But if we do this or this, they'll be the exact same model. Okay? I'm saying things aren't duplicated. Right? So sometimes in other languages, if you had done something like this, it will give you NAs for these. It doesn't do that. It understands that the main effects, that this means all main effects and the interaction, and it understands this means all main effects and interaction again. You don't duplicate vehicle age twice and have a redundant column, for example. Okay, so here, create a expensive column where if the vehicle cost is greater than 10,000, so it's just binary, true or false. Tab, we do a two-way table, whether it's a bad buy versus expensive, and then we use chi_sq.test on the table. We get a p-value. Let's look at the table. So Fisher.test, it gives us a test of independence. Chi-square value, degrees of freedom equals 1. P-value is 0.03. Fisher.test, very similar p-value, a little bit different. Gives us an odds ratio estimate and a confidence interval. Prop.test will also give us a proportion test confidence interval. It'll be a little bit different than the Fisher's exact test, and chi-square.test doesn't give us that at all. So if we do prop.test, it will give us a two-sample proportion test, and it will give us a confidence interval on the difference in proportions. So we're going to fit a logistic regression where the outcome is a bad buy. Remember, we're going to use the GLM status. And predictors are whether it's expensive or not and the vehicle's age. Save the model fit and provide a summary table. So there's a couple different ways you can specify the family. You need to use family with family unquoted, just say binomial. Put parentheses, you can put in quotes. All of these are valid ways of doing it. The outcome is 0, 1. You can put in a binary variable, a logical variable, as a factor if you'd like. You can, but you can make it 0, 1, like actually numeric, or you can keep it as trues and falses. It's fine. Vehicle age is going to be treated as continuous, and we're calling this log fit cars. And again, everything is going to be on the original scale. Or I mean the link scale, right? And if we say confident tidy of log fit cars, that'll run a little bit of profiling to give us the confidence interval on the original scale. We could just run confident, so it's got to do some profiling to get a confidence interval. There are additional options in confident, and again, if we wanted the coefficient table, we can say log fit cars using the tidy function, and then we can also c-bind it together. Because, this is logical, so it won't just come up as expensive. It'll come up as expensive true. It treats the falses as the reference category. If we multiply this by 1, if we made this numeric, true wouldn't be there anymore. It would just say expensive. So it depends how you code your variables and some things. The naming of the coefficients will be a little bit different. So another thing I want to talk about that we didn't really cover in the lecture. So there is an ANOVA command. It doesn't do what you think, but it's still useful. ANOVA, so let's say we fit 3 models. This is it a bad buy with the interaction of vehicle age? This is it a bad buy plus vehicle age, no interaction? This is it a bad buy, interaction with vehicle age? Again, all the main effects are going to be in there, and we added the vehicle year as a factor in there. Okay? 3 different models. ANOVA will do tests, right? So it'll do F tests, right? So we put the first model in there, the second model in there, and the third model in there, and it says, let's do an F test. So what is this actually doing? This first F test is testing whether vehicle year is significant or is predictive in some respects after accounting for the interaction and the main effect of is it a bad buy in vehicle age, and it gives you a p-value for that. And then this is saying, okay, this is the multiplication of the 2, this is the 2 without the interaction, this is testing the significance of the interaction term. So ANOVA does tests, does like F tests. All right. So really quickly, I sent out an email. The final project is due, I think, in 2 weeks. I believe I will follow up if we do need grades, and before that, I do not think we do. It is pretty much a write-up showing with some code either in the write-up or just as an associated R script that shows that you've done some things with the data that you've learned in this class. So you've read some data in, and I would say data of your choosing, but I would like to run the code to make sure it does run. So data that kind of has to be a little bit shareable, so something that's de-identified, right? I will delete everything from that data set once I get it. If you would like to compress whatever you're giving me with a password, you can do that and email me that, and then email my Johns Hopkins email with the password separately in a different email. That is okay. I will delete those emails after I get them. If you want to be very, very cognizant about your data, my office is 3136. You can also drop off a USB drive. You can use JH Box. Any way you can get it to me, you're comfortable with it. It's fine. So I think, really some of the things should show some sort of data cleaning or some sort of data checking, right? Say how many are NAs, how many are missing, and have a little write-up that says this is the data set, a very simple description. This is how many observations. This is how many observations are dropped due to missingness, so on and so forth. Some summarization of the data, looking at means, standard deviations, that kind of things, t-tests or something like that. Maybe some testing, some visualization, 1 or 2 figures that really encapsulate the analyses or whatever kind of relationships you're trying to see, and then we'll write up the conclusion based on the data with some data manipulation going on. Right? You don't have to reshape your data if your data is already in a format that you use it. Okay. So I'm going to give you the choice. So we have about 10, 12 minutes left. I can go over homework 3. There was some confusion on one of those questions, or we can just go over anything. Who would like to go over homework 3? Who would like to go over?
Are you still going to accept homework 3
Yes.
later, even if you go over it now?
Even if I go over it now, yes. Yes. I mean, the homework 3 will be posted in 5 minutes. So I will still accept it after that. Right? The point of this class is to learn. Right? If you are just copy and pasting the commands from homework 3, 1, I will pretty much know. And 2, if you learned that, then I'll accept that. But I'm not gonna. Yeah, I'm gonna wager a guess I write code a bit differently than you might be writing code at this stage. So how about this? If you have questions about homework 3, email me. There was one specific question that I will go over that you would ask about the sorting, and then I want to at least give a point where you say, I don't know how to do this, and I'll write it down in code and I'll put it up to the website. So homework 3. So we read the so sorted. Okay, so the data set we get in here is population level data, right? This country population data using read TSV. TSV. Okay, so we don't know how that data comes in. So what that question says is read the data in, sort it in descending order by population. And you're going to make a new column called sorted. Okay? So we sort on population, we sort it, and then we have the vector of countries now. So now we are going to make a factor out of that vector of countries, and the levels we are going to use is the vector of that countries. But because we've sorted the data set, the order in which they're in is now relative to their population. So I'm saying if I just had, let's read it in. So the data, oh, come on. So the data happen to come in sorted already. But let's say we don't want to assume that. So let's say the data came in this way. And I want to make this country or territory into a factor based on the population in descending order. So first, what I'm saying is I can't just take this vector, this thing of countries, and say, okay, we're going to use it based on alphabetical order. I don't want that. So first, I have to arrange the data by population. Now that the data is sorted, capital P, right? But one, that's not the way I want it either. I want it descending order so that the first country is the one with the most people. Now that the data is sorted, if I grab this, if I make this variable into a factor, and I use this specific order in which they're in, that'll be a factor where the levels mean something other than alphabetical. So what I'm saying is x equals mutate country, let's call it sorted, equals this. Sorry. I want a factor based on these variables, and the levels are based on these variables. If I say head x sorted, we see now that the levels are China, India, US, Indonesia, Brazil. If we look back at the original data, if we look at the sorted data that we have, that is the way they are in the population. Now, I don't care. I don't care how I sort this data set. That variable will always be ordered in the levels that we gave. Okay? So that is what that question was trying to demonstrate. Okay? So you arrange based on a column, grab that vector. Now those are sorted in a particular way based on a different column. Now if we make that into a factor, those are going to stay in that order when we do plotting and all that other fun stuff. All right, question. All right, I don't know how to do.
Okay, so this is just a comment. For number 1 and 6, I have some very strange characters. Like where it says create an integer variable. So between the word integer and variable, there was some special character that I didn't understand. And so I spent hours and hours.
Oh, these quotes.
It didn't say year. It said, I can show you what it looks like. It has like little.
Yeah.
Ah.
It's not translating right.
Welcome to Windows and Mac. It's a font thing. Sorry about that.
And so eventually I decided to ignore that. So
Yeah.
now
So those are things you should email.
well, I didn't know you
Yeah.
were supposed to be asking.
Sorry, yeah. So you see, these are not regular quotes. These are like Microsoft Word or something. Change them. Sorry about that. Yeah. All right, I don't know how to do what in R. And you want to know how to do it.
So this might be kind of like a big question, but is there a way to compare the overall data structure, so not the content of the data, but the variable structure between two data sets?
As in what way? Like,
As in like checking, so we would want all the variable names, the factor levels, all of those things to be identical, but then the individual responses would be different records.
not exactly. If you say, so let's say, what was that data set? Cars. So sapply cars class will give you the class of everything. So let me just scroll back up to that. So I went through every single column and got the class. And
So is there a way, like if you have two data sets,
if you said levels, those that are factors will give you something back for that.
but you would have to like,
You have to programmatically do it. Yeah.
Maths.
Maps. The SP or the GG map package. So the SP package is a general spatial package. GG map is a mapping library for GG plotting. Yeah.
Is there any kind of reference, like, I don't know, if you do pointers and see?
There are. That's a, yeah. We're not going to cover that. Yeah. If you want, so Google writing R extensions, and that is the Bible of writing stuff, writing R packages, and talks about pointers in there. Yeah.
Well, like in state life, you have two data sets. I mean, the same, like you do double entry. You can compare to find inconsistency between the two.
Yes.
Is there anything here like that?
So if they're the same size, same shape, exactly the same data sets, you can just use equals, right? You can just use checks on that to see if they are equal to each other. And then you do information on that. So there's all dot equal, right? And we talked about this at the end of class yesterday. All dot equal. Or you just say like data frame 1 equals data frame 2. And then you use row sums or col sums to get information on how many are different or not. Or you say data frame 1 doesn't equal data frame 2. Something like that.
Can you show me again the code that you used to get all of the class?
sapply class.
Why do you have to put sapply? I'm sorry.
So sapply is saying go through every column of the data set and run the class command. If I just run class command on the data set, it's going to say, oh, it's a data frame. Right? Because it thinks you're only grabbing that one object. sapply will go through every column individually.
And what did you do for the levels one?
Same thing with levels, but it's a little bit different. So levels, but that doesn't give you something that great. So so classes. Actually, let me put these facts. So you'd say like, none of these are factors, I don't think. But let's say we made one of them into a factor. So like cars is bed by fact calls cars facts. So here you say class for everything. Here we're checking if that column is a factor. Here we're just grabbing those exact columns, right? And then we can say on those fact columns, on those columns that are factors, let's run the levels command. So the reason I did this first is because if it's not a factor and you run the levels command, it's just going to come back null. There are no levels to a character vector or a numeric vector. So you're saying let's subset only the columns that are factors, and then let's run the levels command to see those. So it's kind of a two-step operation. Find which ones are factors and then subset them.
Do you do sample size and power calculations in R, or do you use separate?
I do them in R. There's a power, POWR, I believe. I think that's the package. There are a lot of them out. There are a couple out there. Trial size, capital T, capital S, is a really good one. I thought it was called power. Oh, PWR, poor, whatever. Okay, not PWR. Will do a lot of power calculations for you. Different examples on there. There are functions in our power.t.test, for example, power.prop.test, PWR, the PWR package, not PO, PWR package has some of those in there. Trial size, which has some other, if you say help package, trial size, that'll give you the list of functions for that package. So these do a whole bunch of other equivalence, non-equivalence testing, and so forth.
So for how long would I keep having access to your data and your latest?
So they should stay up for until the end of the summer. All the PDFs you should be able to download. All the data should be able to be downloaded on all the links. Yeah. I don't plan on taking that website, but I'm saying at least till the end of the summer they shouldn't go away. All right.